Welcome back. We're continuing to write functions that describe real-world applications. So let's take a look at another one. Let's say a mechanic charges a flat rate of $50 plus $75 per hour. So he's going to charge you $50 to come out to the site, and then an additional $75 for each hour he's out on the site. Mechanics actually make pretty decent money from what it looks like. So we want to write a function that represents the total charge as a function of hours worked. So we can actually, just from there, we can define our variable x as the number of hours worked, number of hours that the mechanic's going to work for you, and we want to write a function that represents the total charge as a function of the hours worked. So a function of the hours worked is going to equal the total cost. So the total cost we've written, or we want to write, as a function of the number of hours that the mechanic is working. So well, first we want to write the function. So we have f of x, and we know he's charging $50 just to come out. So it's going to be $50 minimum regardless of whether he stays at all. And the next cost is going to be $75 per hour. Well, x we've defined as a number of hours, so it's going to be plus 75x. So this is going to be our function that the mechanic is going to use to figure out what he's going to charge us. Or if we're the mechanic, this is the function we're going to use to calculate how much we're going to charge a customer. We're just going to plug in a certain number of hours for x, and that'll spit out a total cost for us. So let's go ahead and answer the question, how much does the mechanic earn for a 2-hour job? So let's say the mechanic works for 2 hours, a 2-hour job. So what we want to find here is what our function is equal to when the number of hours, or a variable x, is equal to 2. So basically what we're being asked to find is f of 2. And we know how to do this. All we do is plug in, where x is equal to 2, so we're plugging in 2 everywhere we see x. So we have 50 plus 75 equals 2. And then we simply solve this. 50 plus 150, 75 times 2 is 150, which gives us $200. So to find out how much the mechanic is going to charge for a 2-hour job, we simply plugged in 2 into our function. So f of 2 gives us $200. It kind of shows you the usefulness of, and pretty much what a function is used for. It's used to find, for one thing, it's used to find for cost. So very, very important. Let's take a look at another one. Let's say Peter earns interest on his investments each month. Let's say his fund earns $1,000 per month. And his fund charges James a commission of 20%. So minus 20% is going to be the commission that whoever's handling his fund charges him, which is, I think this is pretty average. We want to write a function that represents James's earnings as a function of time. Okay, so let's set this up. We know that we're going to have a variable t, which equals time, because we want to write a function of our earnings, or James's earnings, as a function of time. And let's go ahead, since the earnings are given in months, we're going to give the time, we're going to define the time in months. We want to have f of t equal his net earnings. Excuse me, his net earnings, because what we'll really want to know is his net earnings as a function of time. And we say net earnings because we're going to be subtracting a certain percentage for commission. So it's not going to be his total earnings, it's going to be what he actually brings home. So let's go ahead and write our function. Let's change colors. So we have f of t equals, okay, so he's earning $1,000 a month. So he's earning $1,000 per month. Well, time in months is t, we defined as t, so if we want to know how much he's earning total, it's $1,000 for each month, or 1,000 times t. Now, to get his net earnings, this would actually be it if we defined his earnings, or his total earnings, if we define the function f of t as his total earnings. But since we're defining it as net earnings, which is the money he's earning minus the commission, it's going to be 1,000t minus 20% of this. So if we write our commission as minus 0.2 as 20%, it's going to be minus 0.2 times the earnings, times the total earnings. We're taking 20%, we're subtracting 20% away from the total earnings, so 20%, or 0.2, times the total earnings, which we already found out was 1,000t. Okay, so make sure you understand how we got to this part, because this is extremely important. We always want to define our functions correctly. So this is our function. The net earnings is a function of time. So if we want to know how much he earns, his net earnings, in a certain amount of months, we can plug in a number of months and then solve this, and our function will spit out an answer. And that's actually what we're going to do here. Let's say we want to know how much will James's net earnings be after 6 months. So 6 months. So essentially the question we want to ask is, here's our function. We want to know what our function is going to be equal to when t is equal to 6. So we're going to set t equal to 6, because our variable t is already set in months. So t equals 6. We want to answer the question, what is f of 6? And hoping you understand how we got this. We're just plugging in 6 for t. We're defining our variable of time as 6 months. So everywhere we see t in our function, we're going to substitute in 6. And this is actually the first time we see our variable occur in 2 different places, or more than one place in our function. But everywhere we see t, we're going to plug in 6. So we're going to have 1,000 times 6 minus 0.2, sorry about that, 0.2 times 1,000 times 6. Okay, now we simply solve this. So we have 6,000 minus 0.2 times 6,000. Oops, 6,000, excuse me. We get 6,000 minus 0.2 times 6,000 will give us 1,200. 1,200, and then 6,000 minus 1,200 is 4,800. So $4,800 will be James's net earnings after 6 months. So he earns $1,000 a month on his trust fund, or his mutual fund, or whatever kind of fund it is. We're not really told here. And the fund charges him a 20% commission each month. So our function, our net earnings, is a function of time. And what we did is we simply plugged in 6 months into our function as the amount of time. And all we did is simply solve that and to find out our net earnings after 6 months. So I'm hoping you can get an idea of the actual value and the power of a good function. It can solve real-world applications, making our job much, much easier. So we'll practice more of these, and in the next section we'll actually be looking at graphs of these functions, which is actually the ultimate goal here. We want to go from a function, we want to write a table describing our function, and that will actually help us graph the function. When we see the function on a graph, that actually helps us give us a visual representation of what's going on, gives us a better idea of the trend where the function's going. So I'll see you soon.